We are going to talk about adding and subtracting radicals. And what we're actually going to do is revisit adding and subtracting polynomials because they're very similar. Even though polynomials have variables, radicals obviously have a square root sign, the concepts are still the same. So looking back, if I have 3x and 2x, we call these like terms because they have the same variable, same exponent. So what I do when I add them, I add their coefficients to make 5x. Same thing with subtraction. I just put their coefficients together. So this would be 7 minus 4, and that would give me 3y. So the rule for combining like terms is to add the coefficients of the same variables. And that's it. So for radicals, we do the same exact thing. We are going to add the coefficients, but instead of the same variables, our like terms are things that are the same radicals. So if I look at this first example, I have a square root of 2, square root of 2, square root of 2. All of these are the same radical. So this problem right here is essentially the same thing as 3x plus 2x minus 1x. Same thing, if you don't see a coefficient, it's always 1. So you can see these are the exact same concept, but just a different representation because we're working with radicals. So 3 plus 2 is 5, 5 minus 1 is 4, so this is 4 square root of 2. And just like with variables, we do not change the variable, we do not change the radical. We're just tallying up how many of them we have, so we have 4 square root of 2's. Same idea, we have the same like terms, right, same radical. So the coefficients, positive 7 minus 4, we get a 3 root 5. Now, this is where we run into the issue, and this is why simplifying is one of the most important things about radicals because you can't add if you can't simplify. If you look, this is a root 2 and this is a root 8. So at first glance, these do not look like terms. But root 8 is not in its simplest form. I can break this down into 2 and 4, 2 and 2, and I see that I have a pair of 2's that will come out. So this is going to become 2 root, and if you look, my single is a 2. So this becomes 2 root 2 minus 5 root 2. And now we have like terms. So because these are like terms when simplified, we can combine. So 2 minus 5 is negative 3 root 2. And that's it. So I'm going to try a couple of these with you, have you try 1 or 2 on your own, and then we will save the rest for tomorrow. So same thing as above. We have like terms. This is a 1 in front, so 1 plus 5 is going to give me 6 root 3. Same concept here. Like terms, we don't change the terms. We're just tallying up how many root 6's we have. So in this problem, we have 2. We're taking away one of them here and then adding 3 to this one. So 2 minus 1 is 1. 1 plus 3 is 4. So I have 4 of these root 6 radicals. Now the biggies, okay? These ones we have to simplify. So what I like to do is simplify in the area underneath and then write the new problem above it so that way it doesn't get all like chaotic underneath with the simplifying. So I always write the new versions above it. So I'm going to simplify 75. So we have a 3 and 25, 5 and 5. Pair of 5's comes out to make my coefficient, and I am left with a root 3. So root 75 becomes 5 root 3. Root 3 is already in its simplest form because it's already a prime number. And then I need to simplify 27. A 3 comes out. I am left with 9. 9 breaks into 3 and 3. I have my pair of 3's that come out. Now I have to be careful because this was a negative 1. So negative 1 times 3 is going to give me negative 3. So minus 3, and then my single is a root 3. So now if I look at this in its rewritten form, I have 5 plus 1, which is 6. 6 minus 3 is going to give me 3 root 3's. And that's my answer. So I'll do one more and then have you guys try some of the ones on the back. 50, the smallest prime number that can come out is a 2. So I have 2 and 25. 25, a 2 cannot go in, 3 cannot go in, but 5 can go in, and it goes in 5 times, making that my couple. Couples go out, singles stay in, so I have a 5 root 2 now as my like terms, or as my simplified radical. 18 breaks into 2 and 9. 9 breaks into 3 and 3. I have a pair of 3s that will come out. So remember, always draw that arrow so you pay attention to what was in front. I had a -1. So -1 times 3 is going to give me -3, and my single was a 2. And then this plus 5 root 2 does not change. So if we look, all of these are like terms. 5 minus 3 is 2. 2 plus 5 is 7. So my answer is a 7 root 2. All right, go ahead and try number 5 on your own. So pause the video, try 5, and then I will go over it with you. Okay, 8 breaks into 2 and 4. 4 breaks into 2 and 2. Circle my pairs. That's going to go out with the 2 that is already there. So this is going to be 2 times 2. And if you need to write that stuff, just go ahead and write it down here so you can see it. So 2 times 2. Root 2, because 2 is my single, so this is going to make a 4 root 2. 32 breaks into 2 and 16, 2 and 8, 2 and 4, 2 and 2. Pairs of 2s that come out, and a single 2. So again, do all your work down here if you need to write it all out. This is a 3, a 2, and another 2 for that second pair, and then my single 2 is going to go back in. 3 times 2 is 6. 6 times 2 is 12. So this is a positive 12 root 2. So now I'm going to add them together. 4 plus 12 is 16. So 16 root 2 is my answer. Okay. Go ahead and try number 6 on your own. Now there's going to be something a little unique with number 6, but go ahead and pause it, try it on your own, and then restart the video. Okay. 20 breaks into 2 and 10, 2 and 5. 2's come out. 2 times 4 is going to give me 8, so 8 root 5. And again, if you need to do that 4 times 2 and show that work, just do it underneath like that, and then write the answer above so it's in a clean space. Minus root 5 isn't going to simplify. And then I have 3 and 15, 3 and 5. 3's come out, and I get 3 root 5. So all of these are like terms again. So 8 minus 1, just be very careful. This is where people get really caught up, is they forget the 1 there. So 8 minus 1 is 7. 7 plus 3 is 10. So 10 root 5 is my answer. Okay. So let's look at number 8. And let's look at when maybe not everything is a like term. So in these situations, every single item we are working with was a like term. So on number 8, we're going to see that not happen. So I just want to talk you through one problem of that, and then we'll be done. 24 is going to break into 2 and 12, 2 and 6, 2 and 3. Couples go out, singles stay in. Now, if you look, I have more than one single. So those are going to go back in, and when they go back in, they multiply. So this is going to be root 6. Root 6 breaks into 2 and 3. Okay, so that can't simplify. And we worked on this a lot. If it can't simplify, then that's fine. Don't force it to change. It's just going to stay the same. So minus 3 root 6. But here we have a 2 root 2. And that can't simplify, so that stays. So if I look, I have a root 6, and a root 2. Okay, that is the same thing as having different variables. So I'm going to rewrite this a different way. This is like having 2x minus 3x and then plus 2y, right? These are different things. These are different radicals. So those are not like terms. They're different. So don't force things to change that can't. You're only going to add the 2 terms that go together. So 2 minus 1 is -1. So that's -1 root 6. And then that 2y, or the 2 root 2, has nothing to change with, so it's just going to stay the same as 2 root 2. So we'll see that just like we saw with adding and subtracting. Sometimes you have different variables. Sometimes you have different radicals, right? So if you guys look at, let's look at number 11. Go ahead and simplify number 11 on your own. So pause the video, simplify, and then see if you can finish that one on your own. It is a bigger one, so try it on your own, but then if you get stuck or once you finish, go ahead and start the video and I'll go over this as our last one. Okay, 24 breaks into 2 and 12, 2 and 6, 2 and 3. Couples go out, so 2 times 3 is 6, and then singles go back in, so 2 times 3 is 6 as well. This first one, the 5 root 3, that didn't change, so that's just going to come up, right? So 5 root 3, 6 root 6. We already see we have two things that are not like terms, but you never know what will happen here, so we'll keep going. 2 and 6, 2 and 3. The 2's come out, so 2 times 4 is 8, and then the single goes back in, root 3. So if you look, this is a like term, and this is a like term. So we skipped one, but we do have a set of like terms that will combine eventually. So let's see what happens with 54. 2 and 27, 3 and 9, 3 and 3. I have a pair of 3's that come out. Now it's times a -1, so minus 3. And then I have two singles that are going to go back in. So 2 times 3 is 6. So if you look, I have root 3's and I have root 6's. So you can only combine like terms. So the 3's will go together and then these 6's will go together as well. So 5 and 8, when I add the coefficients, that is going to make a 13 root 3. And then I'm going to add the coefficients of the 6's, right? So 6 minus 3 is 3. So I get 3 root 6. So this is where adding and subtracting becomes at its hardest, is when you're working with different like terms. So just remember, it's like variables. You could even, if you needed to, rewrite them as variables, like x's for the 3's, y's for the 6's, so that maybe it could help you see it a little bit better, but just remember to keep the radicals the same. And that's it. So we will pick up with this on Monday in the next day in class. So just leave the rest blank and we are done.